All right, now we have a moon orbiting a planet at a distance, and it takes 50 days to orbit the planet. I think on the second version of the practice test, I actually give you the time in seconds, but let me just go ahead and do that now. We want this time in seconds, so I'm going to do that conversion. And that's 50 times 24 hours times 3,600 seconds. So we're actually going to end up getting that this is 4,320,000 seconds, which is just peachy keen. Now we're going to actually get the mass of the planet using the second version of Kepler's law. So r cubed over t squared is going to equal gm over 4 pi squared. That's the formula, and what we're trying to isolate is this variable right here. So let me just do a small calculation to isolate. So we're going to get 4 pi squared r cubed over t squared with a little g, with the capital G down here, equals the mass. And let's remember that capital G is the universal gravitational constant, which is 6.67 times 10 to the negative 11th. That's on the formula sheet. But we're going to actually put in our numbers. And here, there's a lot of different calculator work we can do. But at the end of the day, let's just calculate it out. So 4 times pi squared times r cubed divided by the time and then also divided by the universal gravitational constant is going to give us a mass of 1.62 times 10 to the 25th. I'm going to give you one small hint. I'm trying to choose Earth-like planets for these example problems. So if you're kind of looking for a guidepost as to whether your answer is reasonable or not, look for a number between 23 to 25 on that power, and you'll know you're good. Now we want the acceleration due to gravity, and that is given by this formula here, g, mass of the planet divided by the radius of the planet squared. So we're going to use 6.67 times 10 to the negative 11th. We're going to multiply that by the mass of the planet. And, of course, we'll include the radius, which will square. And when we work that out, we're going to end up getting a much more reasonable number. So 6.67 times 10 to the negative 11th times 1.62 times 10 to the 25th divided by 5 times 10 to the 6th squared is giving us a gravity of 43 meters per second squared, which means this planet cannot support life because gravity is too large. Just to kind of give you a feel, on a planet like this, if you were able to bench press, say, 160 pounds, on this planet, your maximum bench would be like the bar itself. So bad for life, and I guess if you are into that kind of thing, bad for the ego too. So that is the second Kepler's law problem. We're going to move on to waves and then electricity.